Hello and welcome to Algebra. Again, we're going to continue in our unit. We're going to solve by factoring today. So the zero product property. Basically, if you multiply two things together, for example, if we had x plus 3 onto x plus 2 equals 0, we can separate them. X plus 3 equals 0 and x plus 2 equals 0. How could you remember that? Well, look at Foghorn Leghorn.
Two nothings is nothing. That's mathematics, son. You can argue with me, but you can't argue with figures. Two half nothings is a whole nothing.
So you see, two half nothings is a whole nothing, and he's a mathematician, so we ought to listen to Foghorn Leghorn. So each part of this, you could think of that as two halves of a nothing, is a whole nothing in and of itself. So that's amazing. Anyway, let's look through. Using the zero product property, we can pull apart something that's already factored, and it's pretty easy to do. We're going to look at the first part equals 0, so 4t plus 1 equals 0. And we're going to look at the second part equals 0, t minus 2 equals 0. We solve each part. Subtract 1, 4t equals negative 1, divide by 4, and t equals negative 1/4. Or add 2, t equals 2. So you have both options. Ta-da, we're done. So once you get a factored form, it's pretty easy to solve. Well, what if we have one that's not in factored form? So we're going to factor it. We're going to use the box method on this. There's two different ways you could do that. We could do it by factoring or box. I'll do both. So the box method, we're going to look at this sign. That means that they are the same sign. And we're going to add the factors. I always look at A times C. So 1 times 15 is 15. 15 is 3 times 5, so we have two options, 1 and 15, or 3 and 5, as your factors to get 15. We want something that's going to add to give me 8, and that's 3 and 5. So the first way we can do this is with the box method. So we're going to put together a little box. We have the leading term here, and the last term, the constant, in the bottom right. We also separate this into these two terms. Now, since this is the same sign, what sign is it? It's addition. It's positive. So this is going to be positive 3 and a positive 5. This is a positive 3x and a positive 5x. We're going to put these parentheses here. Since this is a positive, this is positive. Since this is positive, this is positive. And I'm positive about that. Looking vertically, there's an x in common here, and there's a 3 in common here. If you wanted to, you could break 15 into 3 times 5, and it's easier to see that there's a 3 in common. Also, going horizontally, we have an x in common, and you can see here that there's a 5 and a 5 in common there. So x plus 3 onto x plus 5 equals 0. Now if you wanted to do the grouping method, you would have the same basic idea, x squared plus 3x plus 5x plus 15, except you would just group them, the first two and the last two, and find what the GCF is of each. So the GCF, what's the common factor, what's in common, of x squared and 3x is x. Divide, x squared divided by x is x. 3x divided by x is 3. There's a 5 in common here. Pull that out and divide. 5x divided by 5 is x. 15 divided by 5 is 3. And then these two pull into one binomial. And the leftovers get their own binomial. So either way, you end up with the same thing. Commutative property of multiplication says that we can switch these back and forth. And then we set each one equal to 0. X plus 3 equals 0, or x plus 5 equals 0. Subtract 3, x equals negative 3, or subtract 5 from both sides, x equals negative 5. And I don't think we need to do the same thing here. It will be the same process. Now, sometimes you'll get one like this, and the problem is you look at this form we have a 0. If you don't have that 0, then it's going to be very difficult, to use the zero product property if you don't have a 0. We need two half nothings to be a whole nothing. So we need a whole nothing right there at the end. So 18, that's not nothing. We need to make sure that we have a 0 there. So we're going to subtract 18 from both sides. Be careful, these do not combine because they're not like terms. And we have 4x squared minus 21x minus 18 equals 0. If you look back from where we've been going, if this linear term weren't there, or if the linear term were 0x, then you could solve this using the square root method. Remember, if we had a problem like x squared minus 9 equals 0, you could add 9 to both sides. X squared equals 9. Take the square root of both sides. And x equals positive or negative 3. Both of those would work. You notice that works because there's no linear term, but here we do have a linear term, and we're going to have to try to factor. So, is there any GCF in common with all three? Well, here we have 2 times 2. This would be 3 times 7. Here we have 2 times 3 times 3. There's a 2 in common here. Well, I guess with itself, you don't really say that. And we have 3's back here, 7 here, but nothing's in common with all three, so there's no GCF overall. So we're going to have to multiply 4 times 18. 4 times 18, you could double it twice. 18 times 2, 36, times 2, 72. So we have 72, and it's going to be negative 72. And I need to find some factors that subtract to give me negative 21. Well, I like breaking these down into a factor tree. So 72 is 2 times 36. 36 is 2 times 18. 18 is 2 times 9. And then 9 is 3 times 3. So 2 times 2, 4, 8, 24, and 72. So I'm going to form all of my different factors out of these prime factors. 1 in 72 always works, and it's probably a good idea to go ahead and check and make sure that we can't get 21 out of this, because there will be several factors. 72 minus 1 is not 21, so we need to keep going. Can we form a 2 out of these? Yes. 2 and the leftovers are 2 times 2, 4, 3 times 3, 9, 4 times 9, 36. 36 minus 2 is not 21. Need to keep going. Can we get a 3? Yes, I see a 3. Here's a 3. The leftovers we multiply together. See 2 times 2, 4 times 2, 8 times 3, 24. Does 24 minus 3 give me 21? Yes, it does. So even though there are other factor combinations, I don't need those. I can just go ahead and use that one. 24 minus 3 gives me positive 21, but I need a negative 21. So the larger absolute value here will receive the negative. 24 is negative, 3 is positive. And I'm going to go ahead and just use the box method. More of my students tend to prefer that. So 4x squared, we have negative 18. We're going to have a 3x and a negative 24x. Since this is positive, this will be positive, or plus. Since this is negative, this will be subtraction. Now, what's in common vertically? Well, it might be easier to think of this as 2 times 2. This is, of course, 3. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 18 is 2 times 9. 9 is 3 times 3. So it's a little easier with these larger numbers, these larger, they have more factors in them. Then we can look at those individual prime factors and those build, and it's easier to see the GCF. So looking vertically, we see that there is an x, of course, and we have 1, 2 2's. 2 times 2 is 4. Looking vertically here, I see a 3. Horizontally, I don't see anything in common other than the x. Of course, if that x were not in common, you could look and just pull out a 1. That's sort of your default, there's nothing here. But you do have to pull out a 1 if there's nothing else available. 2, I see, and a 3, and that's it. So 2 times 3 is 6. 6 is my factor there. And so this is going to be 4x plus 3, x minus 6 equals 0. Now remember, there's a hand motion, first, outside, inside, last. You can refer back to those videos on that. But we go through and we double check. 4x times x is 4x squared, plus 3 minus 24, that does give me negative 21x, minus 18. So it's good to go back, double check. We spent a good amount of time on that, so we want to make sure that we did that correctly. And now we split it. 2 half nothings is a whole nothing. 4x plus 3 equals 0, and x minus 6 is 0 as well. Subtract 3 from both sides. 4x equals negative 3. Divide by 4, x equals negative 3/4, or add 6, x equals 6. So x equals negative 3/4, or x equals 6, to clean it up just a little bit. Okay, now let's look at an applied problem. This is courtesy of Pearson Education in the Common Core Algebra 1 book. Now, you're constructing a frame for the rectangular photo shown. Photo is 11 inches by 17 inches. You want the frame to be the same width all the way around and the total area of the frame to be 315 square inches. What should the outer dimensions of the frame be? Well, the first step is to read the problem and to try to figure out some sort of a picture for this. So we're going to make a picture, a beautiful frame. And in this frame, we know that it's supposed to be the same width all the way around. Well, that means that this width, let's call x. So this right here is x. This here is x. This is x. And this is x. This is a classic problem, by the way. Very, very often seen. That, or you'll see like a dog run around one length. But you have these unknown widths, and you look at the length and the width. So we have the width would be going left to right. The height would be up and down. And so we're going to look at the area of the frame as it is. They said it's 11 by 17, so this would be 17 inches. And this would be 11 inches. And those dimensions are not exact, but you get the idea. So I need this area to be 315 square inches. Well, if you look at the total height, or length, width, they're interchangeable here. You have an x, an 11, and another x. So there's two x's and the 11 inside. So we have 2x plus 11. That's the entire length or height, however you want to call that. We also have the width. We have 1x, 2 x's, and then this 17 there. So there's 2 x's plus 17. That's the area as it's presented there. But we also have a hard concrete number on the total area, which is 315 square inches. So now this is my problem. You would think, oh, we split this off, 2x plus 11 equals 315, 2x plus 17 equals 315. That's just not, that's not accurate. We cannot do that. The only thing that we do know is that we can use a zero product property. 2 half nothings is a whole nothing, Foghorn Leghorn says. So we need a whole nothing right here. We could subtract 315 from both sides, but we really need to clear this up before we do that. So this is going to be a multi-step process. First, we're going to take those two binomials, multiply them, make a trinomial. Subtract 315 from both sides, so you get a whole nothing. Then we're going to factor that back out again, so that we have two binomials and a 0. That's what we're looking for. So first, 4x squared outside plus 34x inside plus 22x last plus 11 times 17, 187. So we're going to combine like terms. 4x squared plus 56x plus 187 equals 315. We're going to subtract 187 so that we have, remember the zero product property, you need a whole nothing, you need 0. So we're trying to get a 0 there. So 4x squared plus 56x equals, we're going to subtract that and end up with 128. Pardon me, we need the 0 here. This is going to give me 128 here. I don't need the 128 there. I'm going to subtract it. Sometimes we make a mistake. That happens. So we have 4x squared plus 56x minus 128 equals 0. I just had it on the wrong side. So now we're going to look through. Let's see. 4x squared plus 56x minus 128 equals 0. The first thing we're going to look for is a GCF. Is there something in common with all of these? Well, I know that they're all even numbers, so I'm going to try first to see if I can pull out a 2. I can pull out a 2. Once I divide this by 2, I have 2. That's also divisible by 2. Divide this by 2, we have 28. That's also divisible by 2. 64, also divisible by 2. So 4 is going to divide easily into all of these. So 4 onto x squared plus, divide by 2 twice is an easier way to do that. 56 divided by 2, 28. Divided by 2 again is 14. 128 divided by 2 twice, that's going to be 64, and then 32. So now 32 times 1 is going to be 32, or negative 32. I need something that's going to subtract to give me 14. 1 and 32. 32 minus 1 is not 14. 2 and 16. 16 minus 2, that is 14. So this is the pair that I want. They're different signs. The larger absolute value will get the positive, larger number you can think of. So that positive will go with the larger absolute value, and the 2 will get the negative. So now we're going to factor with the box method. X squared, negative 32, negative 2x, positive 16x. Because this is negative, this is a subtraction. Because this is positive, this is positive. Looking vertically, we have x, vertically 2, horizontally x, horizontally 16. So we have 4 onto x minus 2 onto x plus 16 equals 0. Now we need to look, 2 half nothings is a whole nothing. So in this case, there's actually 3 halves, which doesn't quite add up in the video, the dumb thing that we were using, the scaffolding. But we'll still get the idea here. 4 equals 0, x minus 2 equals 0, x plus 16 equals 0. Now why did I set 4 equal to 0? That makes no sense. You're right, it makes no sense. But sometimes you'll have a variable there. If you have an x, or depending on the situation, a y or a z, if you have that there, suddenly that adds another solution. You don't need to add or take away solutions. That's very bad. So in this case, we're just getting into good habit by setting that equal to 0 to make sure that we're not losing any solutions by doing that. So we didn't have any solutions with a 4 equals 0, but we can check for these others. Add 2 to both sides. X equals 2. Here subtract 16 from both sides. X equals negative 16. And if you look at the full context of the problem, what's happened is we have one positive and one negative solution. Well, they ask, what should the outer dimensions of the frame be? Remember, X in our setup here, that's why it's good to draw a picture beforehand, because you can see exactly what is it that we were looking for in the first place. We were looking for that width of the frame. And you could think about your computer or your tablet, the width of the screen going around. It's sort of the same idea. So in this context, the width around is either 2 or negative 16. Practically speaking, there's no way that that can be negative 16 in a geometric sense. You're looking at the length of it, it's not going to be negative 16. So it's going to be 2 inches. This one just when you look at the context of the problem, does not make sense. Now, if they ask in words, you need to answer in words. So the width of the frame is 2 inches. And for clarity, we'll go ahead and circle that. That'll do it for today. Thank you for watching.